Good afternoon, students. So I'm going to try to get across what I consider to be sort of conflicting or at odds timelines. In other words, I think that the mathematicians, left to their own devices with the journals and word of mouth and gradually, publishing this or that, I think the math that I'm interested in inside of Synergetics, the so-called whole number volumes, concentric hierarchy, and so forth, in 100, maybe 200 years, it would catch on and be accepted and be interesting, and there'd be a lot of people making hay with this. In other words, it's not going to be found to be wrong, but it is kick the can down the road. It's like there's no real urgency behind it. It's interesting. We can talk about it someday. Now, the other timeline is like we're on the brink of war with Iran, and there's like housing shortage, and there's a need for positive futurism. And a lot of that was coming from the Bucky Fuller camp, but got put on a shelf. And it's not like there's a lot of time to waste. So if you're going to brand Fuller a crackpot, you have to do that really well because the Bucky camp is going to fight back. And one thing we're going to do is we're going to look at this math that's maybe slated to become important in a couple hundred years, and we're going to try to accelerate it to make it important right now. Why aren't you learning this in high school yesterday? Why the delay? We want to add some urgency. And that's kind of the world game coming in, saying, we don't have time to just be so lackadaisical. Let's really look at this stuff, okay? So those are what I call the warring timelines. There's the sort of ho-hum, maybe someday this will be useful, and then there's the we really needed to be looking at this 20 years ago, 40 years ago, and so on. It's like it's already maybe too late, so there's an urgency there. So let's talk about the Genesis story. I've talked about this under that title in an earlier YouTube. I'm talking about the Platonic polyhedra, which come, how many are there? There are 5. But the tetrahedron is somewhat doubled because it's self-dual, and the rest are pairs, dual pairs. By dual, you can look that up. It's where faces become corners and corners become faces. The edges don't change in number. And we can have the duals be such that they crisscross. In other words, their edges crisscross, and that's what's happening here in this animated GIF. What you're seeing over and over is first the icosahedron appears, and we say it has edges D, which is the diameter of one of these brown balls, and then we crisscross it with its own dual and create from that pair the rhombic triicondahedron, which shows up in purple. And at first it's big, and then we shrink wrap down to the ball. We shrink wrap around the ball so that the centers of the diamond faces are all flush with the cube, tangent to the, sphere, tangent to the sphere at the centers of all 30 diamond faces. So one of the interesting things we found about the volume of that super RT before we shrink it down is it's the volume of the cube octahedron defined by 12 balls around 1 times the second root of 9/8, also known as the Synergetics constant. The thing here that's interesting is we're not trying to go from cubic XYZ volumes to tetravolumes. We're in tetravolumes the whole time. But we're saying that, okay, where's the cube octahedron? The cube octahedron is the yellow shape right here, made by connecting the centers of the 12 balls around 1. So there's a nuclear sphere, a brown sphere with 12 packed around it. You connect those sphere centers with yellow rods and you get the volume 20 cube octahedron. Now the blue casements around each ball, those are the rhombic dodecahedra, and they have volume 6. Exactly, right? So this is all the whole number volumes that we talk about. Here's a chart in CodePen, tetrahedron 1, duotech cube 3, octahedron 4, rhombic dodecahedron 6, Then we get into some phi values for the two duals we started with. And down here at the bottom, what I'm calling super RT is exactly 20 times second root of 9/8. So what we want to do with that super RT, though, is shrink it down so that it shrink wraps a ball. And then what are the dimensions of the E modules? And what do I mean by E modules? Well, we can go to Synergetics figure index and see for ourselves that the E modules derive from taking one of these rhombic tricondyhedrons and crisscrossing each of the diamond faces, creating 4 modules out of each. 4 times 30 is 120. So this is how we get 120 E modules. We also have a plane net, which gives us the actual irrational numbers that we can plug into our volume formula. Let's plug in the 6 edges of the E module and see what we get. And as a check, let's see if when we start with this super RT and shrink it down by 1 over phi, meaning all the edges go down by phi, which means the volume goes down by phi to the 3rd power, and then we take 1/120th of that resulting volume, is it the same as the E module? And that's what goes on in my unit testing over here on the left. I revised the unit test of the E module to match the plane net of the E module given in Synergetics, which could be simplified. If you could go back to having phi in your vocabulary, you can actually simplify these edge expressions, but I'm taking them as is, and I'm taking h, which is the distance from O, the center, out to the diamond center of each of the diamonds. That's going to be the radius of the brown sphere, right? So we're shrink wrapping the sphere. So I'm going to say h is the same as r. R is radius. That's line 150 here. And then when it comes to all of these OA, OB, CA, CB, and so on, these are just copied right out of the figure, right? So I'm just defining the 6 edges of the tetrahedron, and then I feed it to my formula, which consumes the 6 edges, 3 from an apex, and then going around the opposite face. I get those 6 edges, feed it in, and I'm going to compare that with my super RT, volume shrunk by phi to the -3, and then divided by 120 to get an E module. And for these to be equal, they have to be equal to quite a few decimal points, because I'm not just using floating points here. I'm using decimal type, which can go out to 50 or more places. It's up to us. So I'm going to print what the E module is. I'll just say E, and we can look over on the left. When I run all these unit tests together, there are about 26 of them. We'll see to what degree of precision this passes the test. So I hit the green arrow, and I look over here, and I see it passed all the tests. And here's the printout I'm interested in. So that's the value of the E module to about 50 decimal places. Now further down, I'm computing something else and getting the volume there too. In other words, with quadrays, which is what I'm using here, I can start out by taking the 3 quadrays from the center that border any of the 4 quadrants and compute the volume of that tetrahedron, right? 1/4 of what we call unit volume tetrahedron. And of course that gives us 0.25 for its volume, so that works out too. And I have a bunch of other tests of this nature. So the point of all this is to say, hey, all this concentric hierarchy stuff that's in Synergetics that Fuller thought was so important, and it does give us a lot more whole numbers than we're used to when dealing with polyhedra, including the platonics. So there's a lot of interesting streamlining going on here. And do we want to wait 100, 200 years for the math community to decide this is interesting? I'm saying we can't afford that, So in Martian math, we have this sort of accelerated time machine thing where we make it matter today and not in 200 years. We don't have that much time to wait, right? That's the problem with all of us being specialists now. You don't know what's important if you don't have the context for it. And I'm saying world game is our context. And rescuing Fuller from his defamers and his detractors is an uphill battle, and part of that battle is showing how you can't dismiss him in terms of the math. And the whole use of his word, of his meme 4D, even that you can't dismiss easily. Is it that the car was a problem? It did get run off the road. There was that episode. Is it the Dymaxion house was somehow deeply flawed? What was the problem there? Like, let's go back and revisit this stuff, realizing that when Fuller got the Medal of Freedom for Synergetics and for being a genius, this was not just empty PR. This was not just a publicity stunt. There's actually stuff of pedagogical significance here that's being ignored. And I'm saying it's a travesty, and we can't allow it to keep going. So that's the purpose of my YouTube channel in many regards, is to keep this stuff on the front burner and not the back burner. All right, I hope that was elucidating. Talk to you soon.